Talking about integrating iRVision with R-30iB Plus. With the recent release of the new and very exciting revision to FANUC's robot controller, the R-30iB Plus, has a lot of new capabilities, a lot of new technologies, additional processing power, and it turns out that iRVision, the iRVision options for inspection, 2D guidance, and 3D guidance was one of the things that was the most changed. Certainly many other changes, but one of the things that was most changed in the R-30iB Plus rollout. And we have new user interface, new components, new interconnects for the cameras and components, new tools. And I constantly get questions about this, both from our great integration partners and end users, and even internally. And I hope that today I can cover some of the things that you've been wondering about regarding integrating iRVision now with the new R-30iB Plus controller. Now I will add that some of this is a little bit of a review. Some of this material has been available elsewhere before, but I hope that this will be a great resource for you to watch, to listen to, and come back to as you work with and design your applications in iRVision moving into the R-30iB Plus controller. We're going to talk about the components and the connections, how to integrate those, what they are and how to integrate them, and then I'm going to go to RoboGuide using the simulation in the new R-30iB Plus simulator so that we can talk about some of the user interface, the processes, command tools, and particularly one of the areas that's brand new in iRVision for R-30iB Plus, and that's the new snap tool. Let's get started by talking about our components and our connections in our iRVision and R-30iB Plus. What's changed and what hasn't? I want to the big thing I want to start with is camera options. One of the bigger changes in the R-30iB Plus controller, and what we have in the R-30iB Plus controller is a camera that we now call the CXV camera. This CXV camera is a digital camera, and it's not much different from the cameras you're used to using in terms of a tethered camera connecting directly to the robot controller, but this camera connects via a single cable coaxial connection. It's a very powerful connection and very high-speed connection. It's kind of cutting edge in the machine vision industry to allow both the signal, the data communication, control of the camera, and power to the camera to operate over a single cable. I often tell people that if they want a comparison, think about your television cable box, your broadband cable box, and that connection is also a coaxial cable. Broadband coax, able to carry a lot of data, carry it very quickly, and even carry the power. This is going to be a great convenience for those of you moving into the R-30iB Plus. It is identical in imaging capability, identical in form factor, identical in mounting, identical in sensor size, and even identical in the way you would select the lenses, or at least the lens focal lengths, to the old R-30iB COA camera. Now, if you've not worked with that R-30iB COA camera, that's not of much importance to you, but it is important to know that not as much as we think has changed, but it is a different camera. It is available in grayscale and color. And I have a couple of areas here during this webinar that I want to just refer back to the R-30iB vision cameras and vision components and make a quick comparison. As you can see in my little chart here, in the R-30iB controller, we had both a Sony analog camera and what was called a COA, quote-unquote, digital camera. In R-30iB Plus, the Sony analog camera is no longer available. This is not a a secret plan of any sort. The issue is that Sony has actually will no longer be offering that camera in its global marketplace. So the Sony analog camera is no longer available in the R-30iB Plus, and we will be using either the CXV camera or the GigE camera that we've talked about, that we will talk about in just a moment. For those of you who are using Sonys, don't be concerned. There is plenty of stock, and we have commitments available, so that should there be additional orders of the Sony for R-30iB and issues with where we may have to replace cameras due to damage or premature failure, we have plenty of cameras, plenty of the Sony analog cameras to handle all of those situations for the long-term future. But going forward, you'll be using either a CXV or the GigE cameras. That COA digital camera that as it was called in the R-30iB is directly replaced by the CXV camera. If you've been using the COA, simply directly replace that in your R-30iB Plus configuration with the CXV camera. Okay, we also have, of course, the GigE camera options available for iRVision. This is one of those areas where something really hasn't changed too much. We have always we've had over the R-30iB always had GigE cameras available. What is a GigE camera? This is an interesting thing. There's not a lot of differentiation between when we get to cameras, and the thing that mostly differentiates cameras in today's marketplace is the way they communicate with their controller or their computing device. The GigE camera, just like the CXV camera, is a digital camera connection. The difference being that instead of using that cutting-edge CXV or coaxial connection, the GigE camera, as the name would suggest, uses an Ethernet connection. That's a simple Cat6 Ethernet cable. I think Cat5 will work as well, but most cables nowadays are Cat6. And that connects from an Ethernet port to the GigE camera. Bottom line is there's no change. If you're transitioning from R-30iB to R-30iB Plus, no change in how the GigE cameras work, connect, nor is there a change in their architecture. Mounting is all the same. It's essentially the same cameras that you've been used to using if you've used GigE cameras. But for R-30iB Plus, and this is good news for everyone working with iRVision and has an interest in looking at the GigE availability, we have additional camera models now available. So let's look over the GigE camera selections, a couple that have been there and a few new ones that I think you'll find very interesting. First of all, the GigE 640-90GM, and I should add, I think those of you who have used these before know these are all Basler cameras. It is we don't private label these. They're the camera directly from the manufacturer Basler, which is a global, very highly respected global manufacturer of cameras. The ACA 640-90 is supported and still available in parts, but no longer listed on the online corporate price list. There's no need anymore to have this lower resolution camera, which was a match for the lower resolution Sony camera. Any new applications you should transition over to, if you're using GigE, you should transition over to the higher res camera or to the CXV camera if that suits your application. Of course, the camera that we've been using for a long time is the ACA 1300. That's a 1.3 megapixel grayscale camera. I should have added here that is also available in color. But that's no change from the cameras, the GigE camera that was available in R-30iB. Same exact camera, still works in R-30iB Plus. What's really exciting is we have 4 brand new cameras in the GigE line, the GigE lineup, and I'll just go through them quickly. The ACA 1375 in grayscale and 1375 in color. Now you notice these are not different from the ACA 1330 that we currently have, but they have one important difference. in terms of execution, and that is that they have a 24-volt DC power supply, as opposed to previously the ACA 1330 only has a 12-volt DC power supply. Why is this important? We now are making these cameras authorized to use for end-of-arm mounting. And at the end of arm, one of the power supplies that is available is the power supply on the EE connector. That happens to be a 24-volt DC power supply, and therefore having these 24-volt DC cameras makes that very convenient for you to use the camera at end of arm if you desire, if you want to use it at end of arm. We also have a higher res camera. This is the highest resolution available in iRVision. It's a 2.3 megapixel, both black and white in color, and again also a 24-volt DC power camera. All of these are available. A couple of them are still getting authorized and put on the online price list. You'll see them, if you don't see them as you look at it here over the weekend, you'll see them shortly. Another option that's very exciting is that we still are offering an IP67 enclosure. Again, keeping with the theme of what has changed and what hasn't. One way to look at this is, well, nothing much has changed. We still offer an IP67 enclosure just like we did for the R-30iB using the Sony. The difference is that this enclosure is integrated with arrives integrated with a CXV camera, and of course the lens included in the enclosure. The selections are 8, 12, 16, and 25 millimeter. So that's the part that's changed. What hasn't changed is it's still that very easy to use and very sophisticated small form factor of an IP67 camera that can be used fixed mount or robot mount. It has the same mounting as the R-30iB Sony IP67, so if you were using that in your R-30iB configuration for iRVision, it's a direct substitute in terms of the mounting and the package size for this enclosure when you use it in your application. A little bit of an addition and change is that we now have both a optional red or white integrated LED light that's part of the enclosure. This light is an improvement on the old-fashioned ring light that used to be used in the R-30iB IP67 iRVision enclosure. Much brighter light and a much more continuous light, or let's say a continuous or a homogeneous light source over the surface of its illumination. The enclosure allows easy access to the lens. You of course need to focus the lens and change the aperture. But it has the same single cable connection, and we'll be talking about this in a moment, the same as all CXV components, no additional wiring required any more than the wire that you'll be using for the camera itself. Going on into some of the things, what has changed, what hasn't, the 3D laser sensor. What has changed is that the 3D laser sensor now uses the integrated CXV camera inside the camera enclosure, and like before, the integrated light is available, but it will be the light that is featured with the IP67 enclosure that I just discussed. What's really new, once again, single cable connection to the controller, which is the same as with any CXV camera, and no additional wiring has to occur between the camera and the controller and the laser unit or the internal light unit. So you're seeing a theme come about here where some things have changed much for the better because of single cable connections and a better camera, higher resolution camera, and a lot of things haven't changed. The mounting is still the same. The execution and the configuration of the devices is still basically the same. Back to that little comparison where I want to bring this up in certain situations related to the R-30iB. We no longer have, of course, the Sony 3DL available for the reasons I discussed earlier. If you've been using a COA 3DL, that's directly replaced by the CXV 3DL, and you'll basically notice no difference in the configuration or the lens selection for that 3D laser sensor using the COA, using the CXV versus the COA camera. The 3D area sensor is, of course, our flagship product for doing 3D imaging, creating a point cloud, creating a 3D image of the scene for purposes of things like bin picking, 3D part location. A very, very powerful tool. We've used it and both demoed it and have it in use in plant floor applications in many, many circumstances, doing a wide variety of bin picking applications and random part pick applications. The difference here, so that part hasn't changed at all. The difference here, of course, as you're beginning to guess, is that it now has the integrated CXV cameras. However, the same lenses, the same standoffs, the same field of view, even the same camera mounting as the R-30iB cameras. So nothing changes for you when you move to the R-30iB Plus, but it is the CXV camera instead. Only just a single camera connection to the controller for each camera, which we might expect. However, there is no change in the connection from the projector to the controller. That uses the same dual cable run that you've been using in the R-30iB. I should note, just like in the R-30iB, it does require a multiplexer to run the two cameras instead of a single camera on the controller. That multiplexer is included in the 3D area sensor package. Now, we have something that really has been a change and a new product for iRVision in R-30iB Plus, and that is what we call the 3D, I'm sorry, there's a typo there. This is the 3D vision sensor. This product will be available soon. It's a 3D imager that's mountable on the robot arm. For the first time, we have the ability to mount a sensor right on the robot arm and do 3D imaging. It's as small as a 3DL sensor. The measurement area is somewhat similar to a 3D laser sensor, but of course in a cube as opposed to a 2D field of view. It has an integrated illumination for both 3D and 2D imaging. And the most important thing is it's a single shot or one-shot acquisition, which means very fast 3D measurement using this sensor and a full 3D point cloud. Has a single cable connection though, same as all CXV components. So this 3D vision sensor, just a couple of words about why this is important and why I think that we'll be finding more and more applications that lend themselves to 3D imaging because of the availability of this sensor. First of all, as with our 3D area sensor, the 3D vision sensor produces a 3D map or a 3D image, what we might call a point cloud image of the scene, whether we're looking at a tote, whether we're looking at a bin, whether we're looking to depalletize boxes, crates, totes, and so on. All of that processing is done in 3D. Some of the benefits of doing things in 3D are that even if it's a flat surface that we're looking at, and even if the parts may or may not be totally overlaid, the 3D image provides us contrast information based on the height of the object. And therefore, the ability to use this single-shot 3D imager now in visual tracking and even with IR Pick tool means that we will have the opportunity or have the ability to do applications that may not have been all that suitable to 2D imaging. And we can use 3D imaging in these tracking applications. Of course, there's a variety of applications that may have been 2D imaging applications where contrast is a problem, but within the depth image of a 3D color map or a 3D point cloud map, we can see the object and the contrast is derived from the from the height of the image as opposed to the grayscale contrast relative to the background. And as I'm talking, you see some examples of this down here. Sometimes something as simple as presence-absence becomes very difficult because of the grayscale imaging and the perhaps lighting problems, glare problems, and so on. In many cases, 3D imaging with its depth image or 3D point cloud map can overcome these lighting and contrast issues and do something make something that may have been a simple presence absence check that is very difficult with 2D imaging, make it much easier in a 3D environment. Very nice camera package with both 2D, as I mentioned, both 2D imaging capable with a LED illuminator for the 2D and a pattern projector for the stereo 3D image acquisition. I've noted that this is available soon. By soon, I mean within just a few weeks. I don't have an exact delivery date, but I think by the time you've watched this webinar and started to think about how you can use the 3D vision sensor, you'll find that we'll have it on the price list and ready for you to try out. Okay. So we've gone through a whole bunch of discussion of the camera options, what's available, what's new in R-30iB Plus, and what's changed and what hasn't. And that always brings us back to, it seems, this discussion of the design considerations when you're selecting when you're trying to select which camera is best for you. And there's not a great way to answer that question. The best answer, and the one that I usually give, is that the decision is driven by the needs of the application. As I suggested earlier, the key difference in tethered cameras is in the interconnect and then how you integrate those cameras in your application. Of course, there are some situations where the selection may point to a specific camera for specific reasons based on the architecture of the camera. First of all, we do have a GigE camera that offers a higher resolution option, and that may be a consideration for you, although high resolution is not as frequently needed in robotic guidance as it is in inspection. The CXV, of course, has this optional IP67 enclosure with illumination, and I think for a lot of applications that may be the reason you would select the CXV as the option for your application, the ability to have a nicely integrated, fully configured IP67 enclosure with illumination that's easy to integrate, easy to mount either on the robot or fixed. And also, just as a side note, the CXV camera is exclusively used, it's the only camera available in all of the iRVision 3D guidance components. So if you're thinking about 3D, I think the decision's already made for you. You can only go with the CXV camera in those cases. So let's talk about the execution side of things and the integration of these cameras. Here's where I get a lot of questions, and I think once you hear the overall explanation, this is going to almost sound too easy. It'll make things much more easy for you in the long run in terms of integration, and I think it's easier than a lot of people think, and that's just a matter of let's get the word out so you know how convenient these new cameras will be to work with. The CXV camera features single cable connections for all interfaces from the controller to the camera or to any of the camera peripherals. So think about that for a second. Any camera that you're using, any CXV device that you're using with iRVision now only requires one camera cable, one cable. That's whether or not there's a light involved, whether or not there's a laser involved, as is with the 3DL, whether it's the 3DAS or the 3DV. I guess I'll make one caveat there. The 3DAS, of course, has two cameras, but each one of those cameras only requires a single cable for its operation. So as you look through the CPL, kind of deciding on cables, deciding on trying to figure out what you're going to do with this CXV camera, the thing to remember is it's going to be easy. You only need one camera cable to connect that CXV camera to your controller. Now, there's a few different things we got to think about. How do we do that? It is the same cable construct, a coaxial cable, whether you're using fixed cameras, end-of-arm cameras, RTU routing, and so on. Currently a 25-meter maximum length. There is a coaxial cam cable in most of our through-arm robot configuration. And as we'll see in a moment, we have some flex cable options, and the way these are put together is very, very simple, not at all hard to understand once you embrace that idea that you're really only going to need one cable type from point A to point B. So I think that's good news for everyone who is moving to an R-30iB Plus controller. So how do you use multiple cameras? The controller, of course, the R-30iB Plus, is very similar in that context to the R-30iB controller. Each camera has only natively a single port on the controller. And when we want to use multiple CXV cameras, we'll be adding, or you'll be adding, a CXV multiplexer. Now, this multiplexer is a very small unit. You can see a picture of it there. It doesn't really give you an idea of how big it is, but it's only a couple of inches long, an inch and a half wide or so. And up to each multiplexer handles 3 cameras, as you can see from the output side of that multiplexer in the picture. However, if you're going to use more than one multiplexer, one of those outputs has to be used to daisy chain to the next multiplexer, as you can see in these 2 drawings. These 2 drawings represent the way the multiplexer would be mounted if you're using either a cabinet or a B cabinet backplane for the multiplexers. Each of those cabinets allow natively up to 3 multiplexers, which would give you 7 cameras in each case. Theoretically, additional multiplexers can be added, but we don't. At the moment, we're not offering the mounting space for those additional multiplexers, or the native mounting space for those additional multiplexers on the backplanes. In the mate cabinet, currently only one multiplexer can be used. If you have the need for more than one multiplexer in the mate cabinet, get with us or get with your salespeople, and we can work on that for you. Bottom line is, though, it's the same cables once again. All of these cables are a single cable, and you only need a coaxial cable to interconnect all of these. Yes, there will be different cable numbers because the cables do different things, and let's move on to that. So we're offering and available both on the CPL and from parts. We're offering a variety of cables to do the interconnect, and more cables are coming. These are just what we have in the pricing and on the parts lists right now. There are standard cables, and the reason we're using them as standard cables is that they're universal for either the A, B, or mate cabinets. And these cables will connect from the controller, which is called the CRJ3 output, the coaxial output right from the controller, or input to the controller, and to any CXV camera. That means the 3DL, the 3DV, the IP67 Enclosure, the cameras for the 3D area sensor. That connector connects to any of the CXV cameras, or to the cable, connects to any CXV camera, or to the Robot J1 connector for the through-arm camera connection, if that is available on your robot. So these are the cameras available. We have a bunch of alternates, however. The alternates are not universal, so you select them based on the cabinet style. And you can see what I have listed here: A cabinet, B cabinet, or mate cabinet. The ones that we're showing in the CPL are only the universal cables, although the description for these cables does list all of the alternates that are available for any one of those cables, so you'll see that right in the CPL. The standard cables are rolling flex only. Alternate cables, as it shows here, are not flex rated. And there will be we are getting future cables that will be coming online very shortly that will be full flex rated for things like cat tracks and external routing of cables on the robot arm. Okay. Speaking of robot arm, what about end of arm mounting for these devices? Once again, single cable style. The only difference is that the wrist cables we are offering are completely flex rated, obviously, because they'll be mounted to the camera output on the robot, and whether it be right on J3 or at another spot on the robot. Those wrist cables will be completely are completely flexible rated, and you'll see the wrist cables in the corporate price list and in the parts lists. They're readily available. But the bottom line is the connections remain the same. No different connectors, no strange connectors on any of these cables. It's the same connector for every cable, and only a single cable is required for any CXV camera component. Once again, just to clarify, no multiple cables going to a 3DL, no multiple cables going to a IP67 with light source. Or to an individual camera, or to the 3D vision sensor, the new 3D robot arm mounted vision sensor. A side note: yes, you can use multiple devices at end of arm, and while it is not again yet on the CPL, on the price list or the parts list, a remote multiplexer will be available to mount on the end of arm so that you can run multiple cameras right at the end of arm. And that's the more convenient way rather than trying to route multiple cables through the robot arm. So we'll have one cable coming through the robot arm, and then that cable will connect to a multiplexer. Once again, same cable, but it'll give you option for 3 cameras or daisy chain multiplexers, remote multiplexers at end of arm. Okay. So let's switch the discussion in terms of integration to the GigE cameras. The GigE cameras are a valuable resource. It may be well suited to your application, but again, what's the decision process? It is really what is most convenient or what's most well indicated for your application. So of course, the GigE camera, just as it suggests, GigE means it refers us to the idea of Ethernet, and the GigE cameras communicate over an Ethernet cable to one dedicated iRVision controller port. That's always, by the way, controller port 3 on the main board. For GigE, for Ethernet cables in general, usually it's listed as 100-meter maximum. I'm not sure that in your plant floor environment that you want to extend the entire, use the entire 100 meters, but that will be a choice up to you depending on your evaluation of the amount of noise and the amount of interference that might be within that 100-meter run. How do you use multiple, in GigE cameras, how do you use multiple how do you incorporate multiple cameras? You simply use an industrial network switch. An industrial network switch works just like an IT network switch. You have an incoming signal, and then of course it transfers the signal to multiple external devices, or vice versa. The multiple external devices are switched to, technically, the single incoming connection. The thing about GigE cameras is that they do need the standard camera that we have been using still needs a 12-volt power supply or a user-supplied power over Ethernet switch. Now, first of all, how does a power over Ethernet switch work? Well, first of all, we have you select the power over Ethernet that works best for your application. It needs to be a rated PoE switch for industrial use, and you can go to a variety of manufacturers that offer that kind of a switch. The switch will require a 48-volt power supply. That's just the specification for PoE in an industrial environment. And then what happens is the PoE switch injects power into the signal going from the switch to the external devices, the cameras. Again, a variety of applications where you can then power the camera right off of the Ethernet line. The thing I want to point out, however, is that this is only specified, only authorized for fixed mount configurations. Why is that? I've had this question many times over the years, and the bottom line is that PoE, particularly PoE, introduces noise into the line that can be affected by the noise of the EMI and RF noise that is produced by the robot motors and other external industrial devices. So PoE kind of exacerbates that problem, where Giggy or Ethernet connections are susceptible to noise. We only authorize PoE for fixed mount configurations. However, how do you put the thing on the end of the arm? I think I alluded to this earlier. End of arm power for both 24 volt and coming soon 12 volt DC GigE cameras is going to be available through the EE connector. Actually, it's already available through the EE connector as a native 24 volt power supply. It just has to be wired in and hooked up to the camera. For the 12 volt power supply, we are going to be offering a power inverter that mounts on the end of arm that can be used to communicate or used to use the through arm Ethernet capability and still have power to the camera at end of arm without using power over Ethernet. And there are flexible cable options for GigE. Certainly we would recommend that in an industrial environment. And the GigE cables that FANUC offers are all a flexible cable option for GigE. So with that, I'd like to move on to a discussion about iRVision configuration and some of the things that, once again, keeping with my theme, some of the things that have changed, some of the things that haven't changed as we look at iRVision and R-30iB Plus. And to do that, I'm going to work with and work within our RoboGuide environment. Many of you are familiar with RoboGuide. It's a brilliant simulation package that is also capable of completely simulating the iRVision and the machine vision side of the robotic application. This is very unique in the marketplace. If you haven't tried it, if you haven't used it, I highly recommend it. It's an extremely valuable tool, and I hope you'll see some of that as I go through here. This is RoboGuide for R-30iB Plus. If you haven't seen it yet, you'll see a lot of similarities. I'm not going to really go into the RoboGuide package itself, only basically use it to discuss what's going on in iRVision for R-30iB Plus with respect to configuration. But you can see I have a cell here with a CXV camera that's been configured above a table full of parts. Maybe not full of parts, it's got 4 parts on it, but we're going to use this to discuss iRVision configuration in R-30iB Plus. So let's go to, first of all, if we open up our web browser in R-30iB Plus, the FANUC Robot Web Server browser, we'll see a lot of changes. These are visual changes that are not all related to R-30iB, or excuse me, not all related to iRVision. This is a new user interface for R-30iB Plus, and I'm not going to have time to go into all of this, but you're going to, as you start out on your robot, on your Teach Pendant and on your web browser, you're going to see a lot of changes in the user interface, and they're very important, very valuable, and really make the system even easier to use than it already was. But for our discussion, I'm only going to center on the iRVision portion of this. Some of these we'll kind of gloss over just due to time constraints. The Vision runtime screen, the Vision logging screen, the Vision configuration screen are all very similar to what they used to be. And if you're familiar or using the 3D area sensor or the 3D or will be using the 3D vision sensor, the 3DV, for bin picking or other types of random part applications. We still have, of course, the interference avoidance setup and parts list manager, and we'll perhaps talk about those in a different discussion. But let's concentrate on what's new and interesting in the in just R-30iB Plus iRVision. I'm going to start with the Vision Devices screen. The Vision Devices screen is a new way for you to see what devices are connected to the R-30iB Plus controller. Now, of course, let me just give you a caveat here. All of these devices right now are virtual devices in my RoboGuide simulation. I'm not hooked up to anything live, but many of you may know that you, of course, can use live imaging and live cameras even within RoboGuide, particularly the USB camera and the GigE camera that hook right to your computer. I'm not doing any of that right now. All of these cameras are virtual cameras. I also have, which we're not going to look at today, but I also have a 3D area sensor, virtual 3D area sensor set up. The thing that's unique about this new Vision Devices screen is that you can see all the devices in one screen. You can even go to the different devices and do a snap, even change the intensity of the image. Yeah, and see, again, it's not configuring anything, but it's allowing you to see conveniently what's set up and the different cameras that might be configured in your system. Something you really couldn't do very easily with iRVision and R-30iB. This is just one of those ease of use things that's I think very valuable in iRVision for R-30iB Plus. So that's the Vision Devices. You can see what's connected, what's hooked up to your controller. But let's go to the Vision setup. Again, as different as this screen is, you'll find that there are some similarities in this new screen and things you'll recognize if you've used iRVision before. If you haven't used iRVision before, I hope that I'll be showing you something that you can immediately recognize as something that's going to be easy to use, easy to configure. So I've just selected that iRVision Setup tab, and now what we see on the iRVision Setup tab is all of the information regarding our tools that are associated with iRVision. If you're used to R-30iB, you'll notice that this is well, not only a little different, quite a bit different in that everything is available in one view here. You don't have to switch from view to view to see the camera information, the process tools, and the application setup tools. The thing that is, I think, most interesting in this area, aside from the view, is that we have a tool now, or we have a configuration now called the camera data configuration. And what that consists of is both the camera setup and the calibration. So everything that has to do with the camera, its selection, its configuration in terms of robot mounting, LED type, and the type of calibration that happens is all handled through this single screen, this single tool. That goes from setup to calibration, and the processes involved step by step, very easy to approach. The step-by-step process is involved in executing a calibration. Now, for those of you not unfamiliar with RoboGuide, you'll see that I don't have an actual trained calibration here. This is a virtual calibration, so we've skipped over the actual training process, and I won't go into that. But the result still is that we end up with a valid calibration, even in the virtual sense, and we can still examine the information, both the points and the data associated with the calibration. And then we move on to the vision process tools. Now, not a lot, aside from this front-end view, not a lot has changed, but let me just create a new process and you'll see something that's a little different. I'm going to create a test process, just to show you something about what's new in the process itself. But this screen in and of itself is very new. You'll see that all of my options to create a process or camera data or application setup tools have been combined into one screen. And in addition to that, there's some help to the side that tells what this process does, what I might need to use it for, how it might be used in an application. I'm going to select, and that's very convenient. I hope you'll take advantage of that. I'm going to select a 2D single view vision process, and it gives me a description of what I'm going to do, whether it be robot mounted or fixed mounted. And I've given it a name. I can give it a comment if I want. I'm going to click OK. And let's go and edit that process. Now some of this will be pretty, a little bit more familiar to those of you who've used iRVision before in R-30iB, but there's something very new that I want to point out. Let's start first by doing what we normally would do in a vision process, and that is selecting a camera and calibration from the camera data tools that I'm going to use for this particular application in my vision process. I also, of course, need to select a user frame or an offset frame in which that camera is going to be working. But the first thing you'll notice, and this is brand new in R-30iB Plus, is the snap tool. I want to show you how powerful this snap tool can be. The purpose of the snap tool is that, I guess, first of all, it takes over all of the function of camera configuration that used to be just part of the process. So it's been moved to this snap tool, and there's a very good reason for it to be moved to the snap tool, because what's happening is I can have multiple snap tools configure different types of images for use with my subsequent tools in my vision process. The types of things I can do are, first of all, constrain the inspection window in hardware, by the way, so that only a certain portion of the image from the camera is transferred from the camera for use with iRVision. Why is this important? It's important because this can and will reduce processing time as we constrain the amount of area that's acquired by the camera. I can also do something called resolution reduction. And as I'm talking about this, let me point out an interesting thing here. We have now have these help areas, information areas, where we can see information about what's going on with that particular tool. Parameter setting, how it's used, what you would do with that particular tool. So just as an example, I'm going to significantly reduce the resolution of this image. It gives me a warning that I've reduced resolution, but I'm going to significantly reduce the resolution of this image. And of course, some of these other things are the same as they have been. You can still select a light, switching a light on and off from the camera package, the IP67 camera or external device. So what I've done now is I have an image that has significantly reduced resolution. What good is that? We'll find out in a minute. But first of all, it is a much smaller image, much less pixels, but without losing very much data. Let's add, for our example here, another snap tool, and you can see this change in our configuration where I want to add a tool. I'm going to add a snap tool number 2, but this time I'm going to leave it at full resolution. I'm not going to change the window imaging here in this case. So how do we use this powerful snap tool? First of all, I could have different exposure times for each of these. That'd be interesting. What if I wanted to use different exposures to get a different view of these tools, or of these objects, with lights coming from different angles? That's a very popular thing and a very valuable thing to do in machine vision nowadays, and that's something that we really could benefit from. I'm going to increase that window size here. Something that we could benefit from in a variety of applications. But now that I've got these set up, how do we make use of these? Well, let's look at this first of all. I'm going to go to my GPM locator tool and tell it that I'd like to use the image that's been created by snap tool number 1. Let's teach a locator. Let's teach this locator. I'm going to try to find these parts. And now I've found that part, but if you're following along carefully, you'll notice that that part's been found with very coarse resolution, which is okay. I'm going to find all of these parts very easily because they have a lot of edges associated with them. There's going to be no problem in finding those parts, but because I've done it in coarse resolution, the time to execute that find is going to be very, very fast, extremely fast. This time, by the way, may not exactly match your controller, of course operating in simulation, but we do try to simulate the times as close as possible. So how does that benefit me? Now I've found them very fast. Maybe that's all you need to do. Maybe you find that you just need a very coarse find to do your entire pick-and-place application. But what if I'd like a more accurate find? One of the things I might do next, and this is these kind of child tools have always been available, but this is even more important and more interesting with the snap tool involved, is that I'm going to go and create another tool, in this case a blob tool. Why a blob tool? Well, for example, in this application, what if I would like to find have the part found at the exact center of that middle circle? You know, it's very hard to do that with a GPM locator. Why? You can't really accurately place, even using set origin, you can't accurately place the origin of your locate. You don't know that that's exactly in the center of that circle. But a blob, on the other hand, can tell you that it is, can give you information that is the exact center of a geometric feature like a circle. So let's go with that. I'm going to teach a blob here that is just the circle, just that circle. Now, those of you who are familiar with iRVision know that what I'm doing is using a child tool. What does a child tool do? It operates on every instance of the parent tool and returns results for every instance of that parent tool. So once I've executed that find, I'm sorry, I forgot to do one thing. What I want to do is do that in full resolution. That's my snap tool number 2. So let's teach this again in high resolution. There we go. So now I have a very high resolution, very accurate center being extracted for that circle because I've used the snap tool. I used a rough coarse find on the GPM, but now I use a very high accuracy find on the blob. But when I do a snap and find for that, we'll see that the speed of the find of that very constrained view, even in high resolution, is extremely fast. On my simulation, of course, it's not even registering. What might we want to do with that? What if I want to deliver the exact position of that blob as the found position or the pick position for my object? All I have to do is select another tool. This one, by the way, is not new to iRVision and R-30iB Plus, but it's just a good example of how to use these tools. I'm going to use my blob locator tool to modify the position of my GPM locator. So the GPM locator is the parent tool that's located the object, but what I really want to return is the location of the blob. I'll set the reference relative to this first part, and now all of the information that's going to be returned in these multiple parts is going to be the exact center of that object. Let's make sure we're finding them all. There we go. It's going to be the exact center of that object for each of those instances, and there we go. So now what we've accomplished is an extremely fast operation using a coarse find for the GPM locator tool because we have this very new and very powerful snap tool option in R-30iB Plus. The find location has been done at full resolution in the blob locator, but because it's been a constrained locate, it's a very quick application, and we've used a different tool to more accurately find the center of the circle, which is what I wanted to do. Let's do one more thing in the minute or so remaining. I'm going to do something that is very important in most applications, and that is I'm going to make sure that I don't pick up this part right here, because this part is obstructed over my pick area. Let's say my pick area is right at the center of the part. This part I would not want to pick up because it's being obstructed by this other object. I'm going to once again use, and this is not new in R-30iB Plus, but I think many of you will recognize this. But what I'm going to do is to set up a histogram tool, once again using the higher res image, and I'm going to place it just over this part right here, and check to see if there's anything encroaching on that part that's outside where the pick fingers might have to go. How do I do that? First of all, I'm going to set my runtime mask so that it only considers things out in this area. So what it's going to be doing is looking for dark objects out in that area. How do I make it look for dark objects? I'm going to set my range of interest to target only dark objects. And when I run that, we'll see that this third object indeed produces a measurement in range, and that it will indicate to our program that to our configuration that that object is not pickable. How do I want to do that? There's a variety of ways you might want to do that. The way I'm going to do it is through a conditional execution tool, and all I have to do here is select the histogram tool and its percent within range, and if that percent within range is too large, let's say if it's over 5%, I'm going to, I could just ignore that part, but I'm going to add 1 to the model ID. Let's see how that works. I'm going to go back to my process. And now we see that all of the objects that are pickable have a model ID of 1. The object that's not pickable has a model ID of 2. And in the same process, I have done a high-speed, very precise locate by taking advantage of the snap tool, the GPM locator tool in a rough find, and the blob locator tool in a highly accurate find of that circle. So that's about it. We're almost out of time. I hope that you use these ideas to make your applications more efficient, more accurate, and easier to set up in R-30iB Plus with iRVision. I think we have some time for a few questions. And let me get to our screen here. There we go. So I'll go right through these, and we'll get to as many as we can online. If we during our WebEx, if we don't have time, we may do it externally. First of all, does FANUC still offer lights for iRVision? Great question. The bottom line is, in R-30iB Plus, we've removed the lights from our price list. Now, if you're already using a light that you like that FANUC has sold before, you can still get that on the parts list. However, new lights in the new CPL, we will not be offering lights anymore. Why? We simply cannot offer enough lights that meet everyone's needs for applications. And so what happens is we end up not having the light you need, or a lot of times, unfortunately, people will just select a light because we have it, and it ends up being not the right light for your application. What we're doing is providing you with we're going to be providing you with contacts and third-party resources that help you select the lights and can even do lighting evaluations for you. Okay, moving on. Does adding multiple CXVs require a multiplexer? Yes, it does, as we discussed. And there's a follow-on question. Can we? What is the max number of CXV multiplexers? Right now, it is 3 per cabinet. That's 7 cameras. There is a theoretical capability of going to even more multiplexers. We don't have a mounting solution for those yet in the cabinets, but that's that is a theoretical capability that we can move to in the future. Is there going to be a 3D sensor available in IP67? Well, yes. First of all of our 3D sensors are IP67. I maybe didn't mention that. The 3D area sensor has always been IP67. The 3D laser sensor has always been IP67. And the new 3D vision sensor, the 3DV, is also IP67 as well for robot mounting. So there will be all of those sensors in 3D are available, or I guess really we'll just say they are all natively IP67 enclosures for both the cameras and, in the case of the 3DAS, for the projector. Do you have recommended high flex coaxial cables? Well, we do offer rolling flex. When we say high flex, I'm not quite sure what that word means. There are 2 types of flex. There's rolling flex and torsional flex. One is if the cable is bending. The other one is if the cable is twisting. So FANUC on our corporate price list does offer right now the rolling flex cables, which is a high flex cable in terms of its rolling flex. Our wrist cables are high flex, both in terms of rolling flex and torsional flex, and we will shortly have additional cables that are both the high rolling and torsional flex. Of course, it makes sense for you to select the cable that's right for your application. If you have a fixed mount application, you probably don't need a flex cable. If you only have a RTU or a cat track application for running the cable, you probably don't need the torsional flex. Certainly, robot mounted cameras need both rolling and torsional flex, but we have those available. As far as recommending them, I recommend the FANUC cables. If you go externally to buy coaxial cables, you're on your own. I don't have a third-party recommended coaxial cable, and I'll just add to that. It is very hard to find a very good quality high-flex coaxial cable for these types of cameras. So certainly feel free to look at any coaxial cable you wish, but of course, if it's up to you to verify and validate the specification of flex and capability. Can we power a third-party LED light with the CXV cable? The answer is no, we can't. The CXV cable is designed only to work with the standard illumination that's available in the IP67 enclosure or on the 3DL 3D laser sensor. Now, the 3D to use an external light, however, it can be tightly integrated with the vision process, because the vision process allows you to specify an output, a robot output, for example, or a digital output, for example, that would control that light, and the process itself can control that light, and you can configure that right in the iRVision configuration. But that has to be through an external signal, either on the robot output or on the digital output. Here's a great question. Are we still using the same calibration plate for the CXV cameras? Yes. The CXV, all of our cameras still use the same calibration plate. And I guess we're about out of time. I'm going to hand it back to Derek right after this question. Can the new robot-mounted 3D area scanner be used on an older controller? And the answer is the projector can be used, of course, but the cameras for the 3D area scanner, I'm sorry, maybe I'm missing the question. The 3D area sensor has a projector and cameras separate. The cameras, of course, are CXV cameras, can't be used on the old controller. The projector could be. Let me revise that answer. I think what the question is about the 3D vision sensor, which is the robot-mounted 3D vision sensor. I misread that, sorry. Can that be used on an older control? The answer is no. This is a brand new CXV camera, as we mentioned, and the CXV camera is only CXV components are only compatible with the R-30iB Plus controller. So that's about it for me today. I hope if you have additional questions, I noticed there's some more questions coming in. We don't have time, but if you have some additional questions, certainly feel free to drop me a note. I'll be happy to answer them anytime. With that, I'm going to hand it back to Derek.